Okay, so this kind of a problem is going to give me a quadratic equation, and I'll show you how it looks. One of the ways I know it's just going to lead to issues is that the square root method tends to work when you have like a reactant here and a reactant here, because then you'll end up being able to take the square root of both of them. But when you have just like one reactant, it almost never works. So I have I times C times, well, I, C, and E, and then I know my K value. So I is 1.0 molarity, C, oops, and E. I don't have any of this, I don't have any of this. I'm losing this one, I'm gaining, and I'm gaining. So I have 1.0 molarity minus X, and then I have X, and then I have X. Now, I did not follow my rule that I should always follow, and that's that you go ahead and write the equation over here before you do anything else, because you'll get to, getting done with that ice chart, and then you won't know what to do. So I know that from the problem, this has a value of 0.0211, and then I know that I have an X times an X, which is X squared, and then I have a 1.0 minus X. So if I grab this and kind of move it out of the way, and I let the K have front and center here, we can see that we have 0.0211 equals X squared over 1.0 minus X. Now we're going to multiply both sides by 1.0 minus X, because I don't want an X in the denominator. That's my first issue right now. So 1.0 minus X. That'll let these two things cancel, and then I'll have X squared equals 1.0 minus X times the 0.0211. So then my next issue is that I have an X on the left and on the right. So I need to distribute this number to everything. So I'm going to have 1 times that number itself. So 0.0211 minus 0.0211x equals X squared. Then I can bring that X term over to the right-hand side, and I can bring this term over to the right-hand side, and I can set the whole thing equal to 0. So I'll just be adding this to both sides. And then I'm also going to be subtracting that to get it over to the other side. So that I have 0 equals X squared plus 0.0211x minus 0.0211. And this has the same format as ax squared. So in this case, a is going to be 1. bx, so that's the b term. And then plus c. So my c term in this case is actually, it's like a negative, like it's this whole negative value. It's like saying plus negative. So it's that whole term. Now, if you pull up your graphing calculator, you can do the work where you do go into the quadratic function, and then you type in A, B, and C, and then you push enter, and then you can do like graphing, or, you can solve it that way. However, this is where I'm going to suggest that there are faster ways of solving it. But the way that this looks when you actually put it in a quadratic equation, if you're not using a graphing calculator, and this is just to make you aware of what you're going to be doing, is that it's x is equal to minus b plus or minus the square root of b squared minus 4 times a times c over 2a. And then you're going to be putting in that this is 0.0211, so minus that, plus or minus the square root of 0.0211 squared minus 4 times 1 times, and that's a negative 0.0211. I'm going to put parentheses around that. That whole thing's in the square root over 2 times 1. So instead of pulling up the graphing, you can also go in and put this whole number in, and you're going to have to put it in as 2 versions. One version with a plus here, and one version with the minus right there. So it's quite as easy to put in the calculator and, get exactly correct. So I'm just kind of walking through one example, but we've got another way to do this so that it's not quite so cumbersome. 4 times 1 is understood. negative 0.0211. And just so you can kind of see that as being grouped, we're going to do it like that. Oops. Insert 4 times that number. And there's a 1, it's understood. And then it's this whole entire thing divided by 2. So I'm going to do that, and then I'm going to put divided by 2. It's 2AC, but, you know, divided by 2. And so that equation is going to end up giving me let's see, 0, I've got this written down, you know, I've got it right there, 135 molarity. Then I'm going to go back to that same equation, copy it down again, and I'm going to change that to a minus sign, because when you take the square root, like when you do this, it's plus or minus. And then I'm going to do that divided by 2, and that gives me negative 0.156. And we've talked about this before, but you can't have a negative concentration. Like you can't have less than what you started with. So, and if you look over the IRIS chart, we have an X value, and it's just sitting there at equilibrium. So I can't have a negative amount. So it can't be that one. It has to be this one. So that's a lot of fun. In just a second, I'll show you another option for solving this problem.